Hi, this is Chapter 12, Lesson 5 on interpreting line graphs. You're going to need your math book and a pencil. We're going to be covering pages 901 through 904 in your math book today. So we're going to go ahead and go straight to the real world link on page 901. What I would like for you to do first on your own is I want you to do question number 1. I want you to fill in the dollar difference between consecutive years on the lines above. So here what you're going to be doing is when you're looking at this, you're going to take these two numbers that you have here, so the first two numbers, and subtract them because you're finding the difference. Now remember, when you're subtracting these, you need to put the second number, which is the bigger number, on top and subtract. You have plenty of room over here in this area here. If you need additional space, feel free to go ahead and get out a clean sheet of notebook paper. So go ahead and pause your video now and find all the differences between all the numbers between the years 2005 and 2010. All right. So once you've subtracted, here's what you should have come up with. So the difference between the first year, between 2005 and 2006, is $55,000. The difference between the second and third year is $80,000, and then $0, then $45,000, and then $0. So what we're looking here, this is money that's won by master tournament winners. Now, we just had the Masters about a week and a half ago by the time you watch this video. And so this is the type of money that those winners win. So if you're looking at question number 2, it reads, if the data were plotted, would the points, year number first and then the amount, form a straight line and explain? So what that's saying is if you were to plot these points on a coordinate plane, and so 2005 would be the first year, and you would plot it at $1,170,000 would be where your XY coordinate would be. And then you do the rest of them, would you be able to connect the dots and form a straight line? And hopefully you guys said no, because look at this here. If you look at the 80,000 and then down to the 0, there's no increase there. So what that means is when you're plotting those points on a number line, then you're going to end up getting a straight line and not an increase. Now, question number 3, you can see it already showed the answer here, but it says here the master tournament is held once a year. If a line graph is made of these data, will there be any realistic data values between tournament dates? And explain. Okay, so here you can see it says no because there's no money awarded in between tournaments. What that is telling us here is the tournament is only held once a year. So that means in 2009, they awarded one winner $1,350,000. In 2010, they awarded another winner $1,350,000. Now, whatever happened between the tournaments and between 2009 and 2010, there was no other tournament, so there's no opportunity for people to win more money because it's only held once a year. So it's basically telling us that there's no realistic, meaning real data between 2009 and 2010. But on a line graph, we're going to end up connecting the dots or the lines. Yeah, connecting the dots with the line. So basically it's just a connection, and it's really going to show trends, and we'll explain trends in a minute. But there's no real data in between them is what that's saying. All right, let's go ahead and look at the next part here. So to make a line graph, what you're going to do is you need to decide on a scale and an interval. So you're going to actually look at the numbers that you're going to have to plot and graph on the coordinate plane. Now remember, your scale and your intervals, you have to start with 0. Always start with 0. And you have to go up in even increments so for your intervals. So what that means is if you look at this graph right over here, the part that I circled, notice it started with 0 and then it goes up by thousands, 1,000, 2,000, 3,000, 4,000, and so forth. So you cannot go from 0 to 1,000 and then skip to 9,000, 10,000, 11,000. You can't do that. You're going to then graph your pairs, so that means you're going to put your dots there, and then you're going to connect your dots, and you can see the finished product over here in this line graph. So one thing I want to point out is this part right over here, oh, and not that part, but this part right over here that I just circled, where it says line graphs on that little sticky on the side. says here, the lines in a line graph are used to show the differences between data values and may not show precise values between data points. This is what I was trying to explain to you in the previous part about how if money is how money is not awarded in between tournament dates on the previous page. So what that's saying here is this. In 1750, when we're looking at this one, this is the amount that was given, where this is right here, okay? And then in the next year, in 1800, this is the amount that we have. So the number that's in between, this area right here, it's not real numbers because we don't have anything that's real in between. Now, obviously, there is data value that's between on this one because it talked about populations and there is a 50-year difference. So obviously it increased, but we don't know specifically how much it increased, let's say in the year 1775, since we only have data for 1750 and then 1800 and so forth. So looking at this table over here, so step 1 tells you that the data includes numbers 790 million to 6,080 million. So you can see your 790 million to your 6,080 million. So you have to decide how you're going to do your intervals. Now remember, we have to always start with 0. And then looking at these numbers, it's best to go up by 1. Now, by 1,000s. You'll notice here that this is a 2,555, and then it jumps up all the way up to 6,000. We can't just sit there and go from 2,000 to 6,000 on our number line. We have to, or on our line graph, we have to put all those numbers in between. And you'll see that that's what they did over here. So if you notice, between 3,000 and 5,000, if you're looking over in this area here, there's no dots graphed over in this area, but you still have to include the numbers on your line graph. So once you've done that, it says here to let your horizontal axis represent the year. That's your XY number, your X number. And then your vertical axis is your up and down one to represent the population, and then label them. By labeling, it says, give me words, tell me what they mean, okay? They got the labels from this area right here, so you don't have to make them up when you're given a data table. Step 3 says to plot and connect the points for the year. So you're going to put your dots and then connect them. And then, of course, label your graph with the title. So the title for this one is Earth's population right over here. And they got that from this over here. So now it's going to be your turn to go ahead and try this. So what you need to do here is go ahead and pause your video in a moment. You're going to make a line graph of the data that's included in this data table. You're then going to describe the change in the number of building permits filled from 2005 to 2010. All right, you guys, go ahead and pause your video. So you're going to go ahead and follow the guidelines of plotting your points, connecting your dots, and then just describe the change. So basically by that, is it increasing? Is it steady? Meaning, is it like not increasing or changing at all? Is it decreasing? So be sure to use one of those words in your explanation. So here you can see I went ahead and plotted my points. And then I'm going to go ahead and connect my lines. So this is what your line graph should look like. Now remember, line graphs have to have a line in them. It doesn't have to be a straight line, but you do have to make sure you are connecting your dots. So when we go to describe the graph, obviously it's going downward. So what that means is the number of building permits that were filed is decreasing. So it's a simple statement like that. All right, so let's go ahead and look at our next page. Now we're going to be interpreting line graphs. By observing the upward or downward slant, okay, so what that means is upward means it's going up, downward would mean down, going down, okay? So by observing the upward or the downward slant of the lines connecting the points, you can describe trends in the data and predict future events. So, what a trend is, you guys, it's like to follow a general course, all right? So you can kind of like, they do this all the time with clothing. Clothings follow kind of a trend, like a general course of where you think it's going to end up going. Well, similar in this. A trend is like you kind of see in this example how it's going upward here. Notice that the dotted lines that they have in this line graph tells you that most likely it's going to continue to go up in that area. What you would not do is just sit there and say, well, see how this is going up. You wouldn't sit there and do dots that look like this and have it go straight off or even downward, because that doesn't make sense. Since it's continuing to kind of rise, then you're going to assume for this graph, for the cost of tuition, it's going to continue to rise as well. So let's go ahead and talk about that further. So the line graph in example 2 shows the cost of tuition at a college during several years. So we're looking at the years 2002 all the way through 2020. Now remember, 2020 hasn't happened yet, so that's obviously our predicted path. Okay, so we're guessing. And so here it says describe the trend, then predict how much tuition will cost in 2020. So here the trend would be, notice that it's increasing from 2002 to 2012. It's fairly steady, which means that it's not like going from here, and here I'm tracing over, it's not like it went up like that, where it went way up like that. Didn't happen like that. So it just means that it's increasing kind of fairly steady, like your line is sort of being very constant. You have no jagged things that go up or nothing that goes down and then up or anything like that. So this is pretty standard. So you would say that it's increasing from 2002 to 2012 very steadily. By extending the graph, that means we're going to keep going. This is where we're predicting. We can predict that tuition in 2012 will cost a student about, be sure to include that word about, because remember, this is an estimate, about $11,500. So you'll notice that when you look from here to this, let me change colors here. If you're looking from this part to this part, notice that they didn't even skip a whole box, okay? So they kind of went up a little less than half a box. So now look at these two. Look at this to this. They went up, you know, just under half a box. So they're kind of saying the same thing. So they went a little bit higher here, and then a little bit higher, and a little bit higher. And that's how you can kind of predict and estimate where it would be for 2012. Is it an exact amount? Absolutely not. But it gives you a good general idea. So now you're going to try this on your own. Now notice that this one, let me give you a hint here though, this is not a steady increase. If it were a steady increase, if I'm looking at the first two, these guys right here, if it was a steady increase, it would kind of go up sort of like that. So be sure to talk about the increase on this one, how it's a little bit steeper. Okay, so go ahead and pause your video now. I would like for you to go ahead and just give me one sentence to describe the trend and then predict how tall the plant will be at 7 weeks. So that means you need to extend your graph. So pause now. All right, so since this line graph talks about plant growth, be sure to put that in there that we're talking about a plant that's growing. So we're going to go ahead and talk about this. At first, between weeks 1 and 2, that plant barely grew. If you notice that, it's still less than 2 inches. It went from maybe 1¾ of an inch to 2 inches. So when we're doing our explanation, we're going to say the plant grows slowly at first, because it did, but then it increases sharply. So that means, boom, like between weeks 2 and 3, it grew 2 inches, and then it continued to steadily increase from there. So what we're going to do next is we need to predict what it's going to be at week 7. So I went ahead and looked at, so what I'm looking at here on these, I'm looking at where my dots are here. So I'm looking at this dot, and I kind of notice it increased by almost an entire square. So then from here to here, it went up to about another square. So I'm like, all right, so my next 2 dots would be right about this area. So I just kind of continued that trend going upward and increasing about the same amount. So therefore you'll see that what I went ahead and put, that the plant will be about 11 inches tall in week 7. All right, let's look at the last example on your final page. It says, what does the graph tell you about the popularity of skateboarding? So if you look at the graph, it says here numbers sold. So this talks about how popular skateboards are by how many were sold in each year. So the years we're looking at is the years 2006 through 2015. Now I want you guys to look carefully at the graph, and I want you to look at this part right here. What this is called is a break in the graph. So what they did is they obviously have no data values from, I guess, where they're probably talking maybe year 2000. And I'm not really sure why they have that break there. Typically, I would see it on the vertical axis. But since there's no data there, what they decided to do is instead of putting all those numbers, they went ahead and just put that break in the graph. So it's as if you're folding the graph there and kind of folding it over so you don't have any numbers, so you don't see any of that information. But that's what it means. When you're creating your own graphs, please do not include any breaks in your graph unless if you are specifically told to. But that's what that little part means there. So looking at this here, in 2006, you can see that there were 250 skateboards sold. In 2007, approximately, I would say maybe that's about 280-ish. In 2008, about 305, 310-ish. So you can kind of see like how it is steadily increasing. So, and that's what that says here, that the graph shows that the skateboard sales have been increasing each year. And I personally would probably write the word steadily increasing, because each year it goes up, close to about the same amount. So then it says here, you can assume that the popularity of the sport is increasing. That's what that's telling you. Since it keeps getting more and more, so since every year more skateboards are being sold or bought, then you can sit there and assume that, each year that it is becoming more popular. All right. So what you guys are going to do here is you're going to complete the guided practice. I want you to do questions 1 through 5 on this guided practice. So be sure to complete your line graph, connect your dots, and answer the questions in complete sentences, because it does show you describe, and predict. Okay, so be sure that you're doing all that correctly, because remember, we need to be writing in full sentences. All right, you guys, that's it for now, and we will see you back in class.